Good morning, students.
Today we are going to discuss about remaining concepts in graph only.
Okay. Now,
Madam,
So once again previous concept explain cheyna malli. Okay, first ఇది చూడండి, then next again I will discuss that one also. So here A to B, here A to B one edge is there, A to C one edge is there. So B to B there is no, B to A there is one edge is there, and B to B there is no edge. So B to C also there is no edge. Coming to C, one edge is there to A, and there is no edge to B, there is no edge to here. So here this is what undirected graph. So that's why here 4 ones are there. Okay, now see here how many number of edges? 2 edges. Suppose here what is the degree of this one? 2. This degree is 1. This degree is 1. So now here sum of rows equal to sum of column equal to degree of that particular degree of that node. Suppose you can take here. So what is the sum here? 2. Sum of column equal to 2 and sum of row equal to 2. Here this represents what? A, and this represents what? A. Okay, so this nothing but sum of rows equal to sum of columns equal to degree of that particular node. And coming to here B, suppose you can add all these values. Now it gives as a 1 and here 1. So this is what the B, so that what? Sum of rows, that is sum of rows equal to sum of columns. Sum of row equal to sum of column equal to 1. So this is what the degree of that particular node. Which node? B node. And coming to C also same. Okay, so this is what the first point. Now second point, that is matrix is symmetric. So in undirected graph, matrix is symmetric matrix. That is in undirected graph the matrix is symmetric matrix, nothing but suppose the matrix is like this. Suppose you can observe this is the matrix. Okay, this is the matrix. Suppose you can write this one like this 0 1 1. So 0 1 1 nothing but here like this. Okay, and rows into columns and columns into rows. So that means the matrix equal to transpose matrix, then the given matrix is called as a symmetric matrix. Suppose here first you can take this as a row and write it as a column wise, and next you can take this row, write it as a column wise. Now third row, write it in the column wise. So now this is the symmetric matrix. That means this is the transpose matrix. Transpose matrix, this is the given matrix. So this given matrix equal to transpose matrix, then we can call it as a given matrix is a symmetric matrix. Suppose whenever any undirected graph, so you can take that adjacency matrix that gives the symmetric. Point, matrix is not symmetric if it is a directed graph. That means if suppose you can observe here this is the directed graph like this. Here this is the directed graph. Now write down the adjacency matrix for this one. A to A there is no edge, A to B some edge is there, A to C there is no edge, from C to A there is no edge, from B to B there is no edge. In the same way B to C also there is no edge. And coming to here C to A, one edge is there, and there is no edge from C to B, there is no edge to C to C. So that suppose you can like this is the given whatever the matrix we are finding for this particular graph. Suppose you can transpose this one 0 0 1, and next this is a row into column. Sorry, 0 1 0, and this is 0 0 0, and now 1 0 0. What? Rows are converted into columns. So this is not equal to this one. So this is not a symmetric matrix. Not symmetric. This is not symmetric matrix. Okay. So for adjacency matrix for undirected graph is symmetric. For directed graph is not symmetric. Next point, row sum gives out degree. So now see here, row sum gives the out degree, column sum gives the in degree. Sum of column degree equal to sum of row degree. Suppose you can see here, this is some graph. Suppose you can observe here, this is some graph. In this graph, here row sum equal to out degree. That means how many number of rows are instant from here. Suppose whenever the out degree and in degree concept is there, you can take assume as a directed graph. Okay, suppose simply say that the degree of the node, in that case you can treat it as a undirected graph. So if it is a out degree and in degree concept, then you can move to directed graph. Suppose here row sum, this row sum gives what only? Here row sum nothing but what? Out degree. Okay, suppose observe here one row sum, that means 1, this gives 1, means this one is nothing but out degree of this one. That means in degree is 1, sorry, in degree is 1 and out in degree 1, here out degree is also 1. So coming to here in degree 1 and out degree is 0. So here in degree 0 and out degree 1. Okay, observe here row sum for this row sum it gives what only 1. So that it gives it as a what? Out degree sum. Out degree sum nothing but row, and in degree is nothing but, suppose you can take this is the in degree. Now edge is starts from C to A. This is what the in degree. Sorry. This is what the out degree. So out degree nothing but ఏంటి మనకి ఇక్కడ సమ్ చేసాం అనుకోండి. ఇప్పుడు this row sum gives the out degree. That means how many number of edges starts from this, how many number of edges instant to here, that is a in degree. అంటే ఇక్కడ మీకు కాలమ్ సమ్ చేసాం అనుకోండి, అప్పుడు ఏమవుతుంది మనకి in degrees. సో కాలమ్ సమ్ సపోజ్ ఇక్కడ తీసుకోండి, ఇక్కడ కాలమ్ వైజ్ చేసాం. సో ఇక్కడ ఏ కాలమ్ వైజ్ చేసినప్పుడు ఏ తీసుకోండి, ఏకి ఇన్ డిగ్రీ ఎంతండి సమ్ 1, సో బికి ఇన్ డిగ్రీ 1, అలాగే సికి ఒక నోడ్ కూడా మనకి ఇక్కడ ఒక ఎడ్జ్ కూడా ఇక్కడ ఇన్స్టెంట్ అవ్వట్లేదు, సో దట్ 0. సో అదే మనకి ఇది తీసుకున్నాం అనుకోండి కాలమ్ వైజ్. సో అవుట్ డిగ్రీ ఒక నోడ్ ఒక ఎడ్జ్ ఇక్కడ నుండి స్టార్ట్ అవుతుంది, ఏ నుండి స్టార్ట్ అవుతుంది. సో బి నుండి ఒక ఎడ్జ్ కూడా స్టార్ట్ అవ్వట్లేదు. సో సి నుండి ఏంటి మనకి 1 ఎడ్జ్ ఇస్ స్టార్టెడ్. సో దట్ out degree nothing but row sum, in degree nothing but column sum. Okay, so this is also one of the important concept. And next one more is sum of column degree equal to sum of row degree. Suppose any columns sums equal to all columns sums. Suppose 0 here 1, it gives 1 0 1. So here what andi ikkada kuda manaki em avutundi 1 1 0. So 1 plus 1 2, here 1 plus 1 2. That means in degree sum equal to out degree sum. Compulsory undirected graph, sorry, directed graph lo in degree sum equal to out degree sum anedi avutundi. So this is what the concept of adjacency matrix. So one more new concept, that is the incidence matrix. So this is not we are discussed, this is we are not discussed in the previous concept. So incidence matrix, what is the incidence matrix? So used only for edge labeled graph. So whenever the graph is given like this with edges also, so graph kanka manaki ఇలా ఎడ్జ్ తో ఇచ్చారనుకోండి, ఇలా ఎడ్జ్ తో పాటు ఇచ్చినప్పుడు మాత్రమే మనకి ఏమవుతుంది అంటే ఎడ్జ్ లేబుల్డ్ గ్రాఫ్ అనేది ఉంటుంది. సో ఈ ఫామ్ లో, ఓకే, ఈ ఫామ్ లో ఇచ్చినప్పుడు మాత్రమే. అంటే ఒకవేళ ఇక్కడ మనకి లేబుల్స్ ఏమీ ఇవ్వలేదు, సో any labels are not given, so directly you can move to adjacency matrix. So suppose if any labels are given, then you can move to like this. Okay, so here now how we are right, that means instead of adjacency, in the adjacency matrix this that is a square matrix, whereas adjacency matrix is a square matrix. Okay, number of rows and number of columns, that means how many number of vertices are there in the graph, that many number of rows and that many number of columns are there. So whereas coming to the incidence graph, that is not the adjacency matrix. So this is not the adjacency matrix, and this instance matrix is only suitable for undirected graph. So this is suitable for undirected graph. So this is not a square matrix. That means the row side you can that means columns you can take all the edges. How many number of edges are there? E1, E2, E3, E4, E5. So as many number of edges as are there, that means in number of edges in this graph, suppose 10 edges are there, so 10 columns are there. Okay, and coming to the rows, how many number of vertices are there, that many number of rows are there. And coming to the columns, how many number of edges are there, that many number of edges are there. So this is what the concept. So here A to B 1, that means here this edge E1 exists with A and E2. So there is no edge from this A. E to edge starts from B to C as well as C to B. Okay, that's why this is also 0. And coming to the E4, this E4 edge is between A to D. So that here 1. So from E5, coming to the E5, so this edge is from D to B or B to D. So that it is a 0. Now, so now it is here, this is what? Suppose coming to B, here edge from B to A. So that's why here 1. So, and coming to the E2, so there is edge exists between B and C. And E3 edge exists between D to C. So that 0. And E4 is also exists between A and D. So that it is also 0. And E5 is exists from B to D. So that's why, so this is what 1. Now, this is what coming to this C edges E1. So, sorry, there is no edge, and E2 edge on that is D2. Sorry, D C here E2 is C2 B and E3 is C2 D. So remaining all are zeros. And coming to the D, here E1 0. That means E1 edge between A and B, and E2. So this is between B and C. So coming to the E3, so this is between D and C. And coming to E4, this is between D and A. Okay. Now coming to the D. So from D, edge to A1, edge to B, and edge to C. So those edges are E4, E5, E3. So in that columns only ones, and remaining all are zeros. So this is what incidence matrix. Okay. Now, so coming to this, we know that the adjacency matrix. Suppose you can write the your own adjacency incidence matrix for this. So here you can take some simple graph A. Here some simple graph A to B, E1, and this is E2. So in this case, like this. Suppose here D is also there. This is what? Like this, this is some graph. So how you can write here? So on the row side, you can take all the vertices. Row side you can take as vertices. On the column side, this is E1, E2, E3, E4, and one more is also there, that is E5. Okay, this is what the E5. Now, this is what edges. On the row side, you can take all the edges. Okay. Now, A1, that means from A, E1, E2, E3. That means 1, 1, 1, and remaining E4 and E5 edges are not from A. And coming to the B, E1, E2, E5. That means E1, E2, 0, 0, and E5. And coming to the C, E4, E3, E5. Okay. E4, that means there is no E1, E2 is there, and there is no E3, E4, and E5. And coming to the D, like this. Here, this is what E1, there is no E1 from D, only E3, E2, E4. So E2, E3, E4, that's no E5. So here, this is what the incidence matrix. So now what is the here 2? That means even degree, even edge between A and B. So that's why this is 2. And E2 edge between A and C. So coming to the E2 edge between A2 and C2. Okay. B2, oh sorry, here 0, and next E2 and D is also 0. Okay, isn't it? This is 0. Okay. Now E2 edge between A and C only. Figure చూసి కూడా మనం చెప్పేయచ్చు. And E3 edge between A and D. And here E4 edge between D and C. And coming to E5 edge between C and here చూడండి A. So this ఇది observe చేశారనుకోండి, this gives the degree. This gives only degree. So degree of A is 3, degree of B is 2, degree of C is 3, and degree of D is what? 2. So here 3, here 2. So degree of A is 3, and degree of B is 2, and degree of C is 3, and degree of D is 2. So this is what the incidence matrix. This is called as incidence matrix. Okay. Next point, adjacency list. So we know that this adjacency list is suitable for simple graph and for undirected graph. So this is suitable. Adjacency matrix is suitable for directed and undirected graph. Incidence matrix is suitable for undirected graph, whereas coming to the adjacency matrix is also suitable for simple graph and as well as for undirected graph. So see here, this is some graph. So in this case, adjacency matrix లో ఏంటి మనకి ఏముంటుంది adjacency matrix లో అంటే here for this example only. So ఈ example చూడండి, how many number of vertices are there, that many number of lists are there. That means A, B, C, D. So మనకి ఎన్ని vertices ఉంటే అన్ని లిస్టులు ఉంటాయి. So A to B edge is there and A to D also edge is there. Okay, B to A edge is there and B to C edge is there, B to D edge is there, and C to B as well as C to D. Next D to A and D to B. Next D to C also. So these all are the concepts. So ఇక్కడ మీరు రాసుకోండి, ఇది B. సో నేను తప్పు రాశాను. సో కట్ చేసి ఇక్కడ మీరు నోట్స్ రాసేటప్పుడు ఇక్కడ B తీసుకోండి. Okay. So this is what the adjacency matrix. Now next concept. So before going to operations and graphs, so first we can discuss about this one, that is the theorem. So while discussing the theorem, I'm in mood. Now see here this theorem. So this is what the important concept, that is delta less than or equal to 2E by n less than capital delta, minimum degree and maximum degree. So this is nothing but, suppose here this is some theorem like this, 2 to the power of E divided by n. This is a floor concept and delta. Okay. Now, so this is important one. So this is a important one. Okay. So because this is what the minimum degree and this is the average degree and this is what the maximum degree. This is what the maximum degree. Suppose here this is some graph like this, B and C like this. This is some graph. So this is some graph. So in this graph, suppose here what is the minimum here, what is the degree here? 3. So here degree is what? 3 and self loop kabatti ka degree ఎంత ఉంటుందండి? 3. Here 2, here 2. So self loops are there, you can count it as a 2 times. Okay, here 3. Now write the degree sequence for this. So how we can write the degree sequence for this? So degree sequence minimum to maximum, 2, 2, 3, 3. Okay, so this is what the minimum, this is what the maximum. Suppose you can take like this. So in this case, what is this? This is 4, means this is what the 4. Okay, now here how many number of, what is the size means number of edges. So number of edges equal to how many number of edges? While counting the degree we can take as a twice, whereas counting the edges we can take it as only one time. 1 2 3, this is h1 2 3 4 5 6. That means 6 edges are there. And coming to the order, order means number of vertices. That means n equal to what? How many number of vertices are there here? 4. Now here minimum degree is what? 2. Less than or equal to 2 into how many number of edges? 6 divided by 4, and maximum is what? 4. So this gives what? Only 3. That means 2 less than or equal to 3 less than 4. This gives the average. So this is nothing but average degree, and this is the minimum degree, and this is the maximum degree. Okay. Now here this is suppose ఇలా ఇచ్చారు అనుకోండి, అప్పుడు ఇది దిస్ కాన్సెప్ట్ ఈజ్ నథింగ్ బట్ ఫ్లోర్ అవుతుంది. సారీ, సీల్ చేస్తున్నాము. సో దిస్ ఈజ్ నథింగ్ బట్ ఫ్లోర్ అవుతుంది, అంటే హైయెస్ట్ అవుతుంది. ఓకే. సో నెక్స్ట్ వర్టెక్స్ కనెక్టివిటీ, దిస్ ఈజ్ ఆల్సో ఇంపార్టెంట్ ఫార్ములా. సో ఆఫ్టర్ డిస్కసింగ్ దిస్ what is the vertex connectivity and edge connectivity, then we can discuss about this one. Okay. Next, see here operations on graph. So these all are the operations here, operations on graph. So here A to B, and this is one graph and this is one graph. So like on sets, different operations are there. So in the same way on the graph also we can do some same operations, that is a union operation as well as intersection operation. Next, union, intersection, complement, like this, all are the different operations on these graphs. Now here G1 and G2 are the graphs. Now G1 and G2 are the graphs. Okay. G1 and G2 are the graphs. Okay. So in this case here G1 union and G2, that means V of that means coming to the node vertices. So how many number of vertices are there here? That many number of same those vertices plus this. Okay, union. That means this graph contains here, for example, here A, B, C. Next A to B and C. Next like this D. So this is G1, this is G2. Okay. So G1 vertex of G1 is nothing but what? A, B, C. And vertex of G2 is nothing but what? A, B, C, C and D. So V1 of G1 union G2 means what? A, B, C, D. So coming to the edges, edges of G1 equal to what? And A comma B and A comma C. Next B comma C. Okay. And here edge set, that is edge set of this graph G2 equal to AB and AC, next BD, next DC or CD. Okay. So whenever we can write within the flower basis, that is A to B as well as B to A. Okay. Now how many number of edges are there in the G1 union and G2 lo? Emuntai manaki, that is A to B is there and A to C is there and B to D is there. Next AB, AC completed and BC is there. Okay. Then next BD, already we are right here, BD. Okay. AB, AB is there, and here AC and AC is there. Next here, coming to here BD, here also BD is there. Next BC. Okay. Now, so this is what G1 and G2. So while you are writing the diagram, that is A, B, C, D. A to B is there and A to C is there. Okay, as well as B to C is also there and B to D is there. And next, so one more we are not, that is C to D. C to D. So like this is the C to D. That means here how many number of vertices are there? 1, 2, edges 1, 2, 3, 4, 5, 6, 7. So out of these 7, so 2 are same. Those are AB and AC. 2 are same. So remaining all are different. So this is what the Z1 union Z2. Okay. Now here this is A, B, C and A, B, E, D. Okay. Now A, B, C is completed. E, here you can write, while writing the notes, you can take it here D. Okay, then paina idi. And next one more graph. This is A, D, C, A, E, D, F. So A to C is there. Okay, A to F is there. So like this, A to F is there. Next, from D to F is there, D to F is there and D to C is there. Okay, the next A to D is there, A to D is there and D to E is there. Next E to A is there. So inside ante manaki ila G1 union G2 vastundi. So then next this is another graph. Suppose A, C, B. Okay, P, Q, R, S. So no common adjacency is there like this. This is two components. Ante so this is one component in one graph. This is the other component in other graph. Ante సో ఇది G1 గ్రాఫ్ లో ఒక కాంపోనెంట్ ఉంది, G2 గ్రాఫ్ లో ఒక కాంపోనెంట్ ఉంది. సో ఈ రెండింటిని మనం కంబైన్ చేసినప్పుడు ఏమవుతుందంటే సింగిల్ గ్రాఫ్ లో 2 కాంపోనెంట్స్ ఆర్ దేర్. ఓకే, యూనియన్ ఆఫ్ 2 వర్టిసెస్ జాయిన్ ఆల్వేస్ కనెక్టెడ్. అంటే యూనియన్ ఆఫ్ 2 వర్టిసెస్ వర్టెక్స్ జాయిన్ ఈజ్ ఆల్వేస్ కనెక్టెడ్. అంటే ఒకవేళ మనకి కామన్ గా ఉంది అనుకోండి అప్పుడు కనెక్ట్ అవుతుంది. ఓకే, కామన్ వర్టెక్స్ ఉన్నప్పుడు కనెక్టెడ్ అవుతుంది. కామన్ వర్టెక్స్ కనుక అంటే కామన్ అడ్జసెన్సీ ఏమైనా ఉంది అనుకోండి, అంటే ఫర్ ఎగ్జాంపుల్ ఇక్కడ P అనేది ఇంకొకటి ఏమైనా ఉంది అనుకోండి, అప్పుడు P to Q అంటే కామన్ వర్టెక్స్ ఉన్నప్పుడు మాత్రమే మనకి కనెక్టెడ్ గ్రాఫ్ అనేది ఎగ్జిస్ట్ అవుతుంది. అదర్వైజ్ కనెక్టెడ్ గ్రాఫ్ అనేది ఎగ్జిస్ట్ కాదు. ఓకే, సో నెక్స్ట్ కాన్సెప్ట్ దట్ ఈస్ ఇంటర్సెక్షన్. సో ఇక్కడ మీకు ఇది రాలేదు, నేను ఈ ఫిగర్ మళ్ళీ ఇమేజ్ మళ్ళీ సెండ్ చేస్తాను. సో నౌ సీ హియర్ హౌ ద ఇంటర్సెక్షన్. సో కమింగ్ టు ద ఇంటర్సెక్షన్, లేదంటే ఇక్కడ రాస్తున్నాను, రాసుకోండి. సో నౌ ఇంటర్సెక్షన్ ఆన్ గ్రాఫ్స్. సో ఇంటర్సెక్షన్ ఎలా ఉంటుంది? ఫర్ ఎగ్జాంపుల్ సపోజ్ హియర్ A and B, next here C. So this is some graph A and another graph is like this, AB and D and E. So this is the another graph. Then A intersection B is what? So here you can observe here A, B, C are there. In the vertex set A, B, C are there. Here A, B, D, E are there. So intersection of these two, V1 and V2. What is the intersection of these two? Intersection of these two is what and A and B only. That means graph low. That means graph G of A intersection B. అంటే ఈ రెండు గ్రాఫ్ ఎలా ఉంటుంది మనకి? ఓన్లీ ఈ వర్టిసెస్ మాత్రమే ఉంటాయి. దట్ మీన్స్ A and B. And next you can observe any edge between these two. And here A to B edge is there. Here A to B is edge is there. Suppose here there is no edge like this. So in the graph only vertices are there. There is no path. So this is called as a tribal path. So there is no path. But graph is there. There is no edge. Okay. Suppose here edge is like this. Here edge is there. Now like this. Okay. This is what the concept. Suppose here A to D2 is there. Now like this. Suppose you can take here B, here D. So in this case here D is there. Now A to D is there, but A to D is there, but here there is no. So but D is there, but there is no edges. So this is some graph. అంటే D అనేది గ్రాఫ్ లో ఉంటుంది, బట్ ఎడ్జ్ మాత్రం ఎగ్జిస్ట్ కాదు. బికాస్ A to D కానీ B to D కానీ మనకి ఎడ్జ్ అనేది లేదు కాబట్టి ఇక్కడ మనకి ఎడ్జ్ అనేది ఫామ్ కాదు. ఓకే, సో దిస్ ఈస్ వాట్ ద intersection. That is, here suppose some other example is like this. Here A to C and like this, and P A to B and here P, here Q. Then in this case A intersection B nothing but what and A intersection B nothing but here the common element. Here the common elements వచ్చేసి A and B. సో బట్ ఈ రెండింటి మధ్యలో మనకి గ్రాఫ్ అనేది ఏమీ ఉండదు. సపోజ్ ఇన్స్టెడ్ ఆఫ్ A here D ఉంది అనుకోండి, ఓన్లీ ఇంటర్సెక్షన్ లో ఏముంటుంది, A మాత్రమే ఉంటుంది. ఓకే, నౌ సపోజ్ వన్ మోర్ ఎగ్జాంపుల్ like this. Suppose here A to B, next to C, D, and here P, Q. So in this case G1, so this is G1 and G2, and here this is not possible because there is no common vertices and there is no common vertices levu ante automatically common edges undavu. Okay, so if two graphs so which are vertex disjoint, then intersection is not possible. So the meaning entandi, that is this is nothing but what andi, disjoint sets. So disjoint sets nothing but entandi, V1 intersection V2 equal to null set. So then this is called as a disjoint sets. Ante okakela graph lo if two graphs which are vertex disjoint, then intersection not possible. If two graphs so which are vertex disjoint, then intersection is not possible. Intersection అనేది possible కాదు. ఓకే, అదే ఎడ్జ్ డిజాయింట్ ఉంది అనుకోండి. సో ఇక్కడ ఎడ్జ్ డిజాయింట్ ఉంటే ప్రాబ్లం లేదు. ద ప్రీవియస్ కేస్ మీకు ఎడ్జ్ డిజాయింట్ ఉంది అంటే ఎడ్జెస్ కామన్ గా, దట్ ఈస్ ఎడ్జ్ డిజాయింట్ ఉంది అనుకోండి, వర్టెక్స్ రిపీటెడ్ గా ఉన్నాయి, ఎడ్జెస్ మాత్రం లేవు, అప్పుడు మనకి గ్రాఫ్ ఫామ్ అవుతుంది. సో హియర్ గ్రాఫ్ ఎగ్జిస్ట్, బట్ వర్టెక్స్ డిజాయింట్ ఉన్నప్పుడు మాత్రం గ్రాఫ్ అనేది ఎగ్జిస్ట్ కాదు. Okay, so this is what the concept. Okay, and here suppose here V1 like this, V1 G1 intersection G2 equal to G1 intersection V of G2. Okay, then next, sorry, not V1, B only, E of G1 intersection G2 equal to E of G1 intersection E of G2. ఎప్పుడు ఇది డిజాయిన్ కాకపోతే మనకి పాసిబుల్ అవుతుంది. ఒకవేళ ఎడ్జ్ కనుక వర్టెక్స్ డిజాయింట్ అనుకోండి, అప్పుడు మనకి ఏమవుతుందంటే గ్రాఫ్ అనేది ఫామ్ కాదు. ఓకే, వర్టెక్స్ డిజాయింట్ ఉంటే గ్రాఫ్ ఫామ్ కాదు. దెన్ కమింగ్ టు ద యూనియన్, ఒకవేళ ఇలా ఉంది అనుకోండి, E of, సో ఇన్ దిస్ కేస్ E of E1 ప్లస్ G1 E of G2 మైనస్ G1 ఇంటర్సెక్షన్ G2, అంటే కామన్ గా ఉన్నవి మైనస్ చేసేసి రిమైనింగ్ తీసుకున్నాం. ఓకే, సో దిస్ ఈస్ ద కాన్సెప్ట్. G1 అంటే V of ఇంటర్సెక్షన్ అండ్ ఎడ్జ్ ఇంటర్సెక్షన్ అండ్ దిస్. సో ఇక్కడ ఎడ్జెస్ ఉంటాయి. ఒకవేళ యూనియన్ చేసినప్పుడు ఏమవుతుందంటే సో కామన్ ఎడ్జెస్ మనకి మైనస్ అవుతాయి. ఓకే, నెక్స్ట్ కాంప్లిమెంట్. కమింగ్ టు ద కాంప్లిమెంట్, here coming to the complement, nothing but G complement. G complement means here G complement nothing but Kn minus G. Here Kn nothing but Kn regular graph. N regular graph. Kn nothing but n regular graph. Okay, n regular graph. So akka nundi ante n regular graph nothing but complete graph. Okay, complete graph. Complete graph. So complete graph nundi manakunna vertices kanaka minus chesam anukondi, it is nothing but G complement. So this is the simple graph. So this is what the simple graph. Okay, for example A, B, C, D. Okay, this is the graph. Okay, what is the G complement here? G complement is nothing but A, B, C, D. How we can write this one? Complete graph for this one is what, Andy? What is the complete graph here? A, B, C, D. Complete graph in the sense, suppose you can pick this one. So remaining all vertices are adjacent to here. Okay, this is the complete graph. Now ఇందులో నుండి ఏం చేస్తున్నాం, ఈ ఎడ్జ్ ఉంది మనకి ఇక్కడ, అంటే this is we are not take. So this is also exists, we are not take. This is also exists. So this is the complete graph. This is the complete graph. Okay, ఈ కంప్లీట్ గ్రాఫ్ నుండి మనం ఏం చేస్తున్నాం, G ని మైనస్ చేస్తున్నాము. సో దిస్ ఈస్ ద కంప్లీట్ గ్రాఫ్. ఇక్కడ నుండి G ని మైనస్ చేస్తున్నాం. Then it gives what అండి, G complement. So now this is what the G complement. అంటే అందులో లేనివి కాంప్లిమెంట్ అంటే we know that. సో యూనియన్ నుండి సెట్ గివెన్ సెట్ ఆఫ్ వర్టిసెస్ మైనస్ చేసాం అనుకోండి, మనకి ఏంటి కాంప్లిమెంట్ అనేది వస్తుంది. ఓకే, నౌ హియర్ వన్ మోర్ పాయింట్, దట్ ఈస్ G1 union G dash equal to what అండి, isn't it? Complete graph. Okay, and G1 intersection G equal to what? Null set. Okay, complement graph and its given graph and its complement. Given graph and its complement gives intersection of given graph and its complement gives what? Disjoint set, or sorry, null set. Okay, these two are the disjoint sets because here what? Edge disjoint. So here edge disjoint is there. Okay, this is not the vertex disjoint, so this is the edge disjoint. Okay, and here this is what the complete graph, it gives as a complete graph. This is what the complete graph. Suppose the graph is like this. Okay, here one more graph, the graph is like this. Suppose A, A, B, C, D, E. So this is some graph. Here how can make it as, complete graph like this. So edge is B to E as well as C to D. Next B to A, B to C, next E, next D. So coming to C, B, D, A, next E. And coming to the D, C, E, B, A. Coming to the E, A, D, C, B. Okay, this is for the complete graph. This is the complete graph, and the given graph is like this: A, B, C, D, and next this is what the given graph. Okay, so this is what the given graph. Okay, this is the given graph. Then what is the G complement? Okay, all vertices are there. B, D, E, all vertices are there. A to B edge is there. Okay, we are not. B to C also we are not. C to, so first you can see A to B and A to C. So remaining all are there. That means A to this is there. And coming to the B, now B to A, B to A is there, B to C is there. So remaining this is not there. B to E and next B to D. And coming to the C, C to A, C to B, C to D. So there is no edge from C to D, C to E. So that you can take it as this one. And coming to the D, so for D to C and D to E. Okay, so that this one is there and this one is there. Next, for D completed. For E, so there is an edge, E to D is there. Okay, So we are not take this one and remaining 3, D2A and D2B and D2C. So this is what the G complement. Okay, this is what G complement. Okay, now you can observe here G complement nothing but K5 minus G, and G in union G complement equal to what? K5. Okay, it is the manaki this one. So G intersection G complement equal to null. So ఈ రెండిటి ఇంటర్సెక్షన్ తీసుకుంటే మనకి ఏ హెచ్ కూడా కామన్ హెచ్ అనేది ఉండదు. సో దిస్ ఈస్ వాట్ ద G complement. G complement. Okay. So next one next one is one more operation on this. Here G with the order n, G with order n, size E, G have order n into n and size n minus n into n minus 1 by 2. Suppose see here Z with order n, size E. Okay, so here what is the order here? Order equal to, sorry, write down just order in the sense what? N. So here n equal to 5 and E equal to what? And how many number of edges are there? 1. That means in undirected graph it is the complete graph. How many number of edges are there? N into n minus 1 divided by 2, isn't it? Complete graph లో మనకి ఎన్ని edges ఉంటాయి? n into n minus 1 divided by 2, isn't it? That means what is the degree sum of this is n into n minus 1. So this is what the degree sum, and this is what the number of edges. So otherwise you can count 1, 2, 3, 4, 5, 6, 7, 8, 9 and this is 1, 10. Okay, write down otherwise 1, 2, 3, 4, 5, now 6, 7, 8, 9, 10. Okay, n into n minus 1 by 2. So here n equal to 5. 5 into 5 minus 1 by 2. That is nothing but, that is 2, 10 and degree sum. That means the degree is here 4, here 4, here 4, here 4, here 4. Sum of degrees equal to 4 into 5. Each and every 5 vertices are there and every vertex degree is 4. So the total is 20. Okay, n into n minus 1. Now here n equal to 5, E equal to what and how many number of edges? 10 edges. Okay, akkada emannaru n equal to 5 and E equal to 10. Then so this is what complete graph. Okay, G with order complete graph and G with order n. So ikkada Z lo order enta and ikkada enta 5, n equal to what and sorry E equal to what? 1, 2, 3, 4, 5. Then ikkada here how many number of, so in this case that means complement graph contains the order is same. Coming to the size, that means number of edges are n into 1, this is 1, this is 2, this is 3, this is 4, this is 5. So coming to this here order is same and number of edges are n into n minus 1 divided by 2, that is 5 into 5 minus 1 divided by 2, that is 10. Suppose here one more like this, but you are not take this one.